Okay, we're recording, aren't we? Fantastic. Phantasmagorical. Okay, I wanted to get into some of the more interesting questions in 7C. We're going to look at question 5. We have to solve this equation, i.e. find out what x is. Now, apparent, what's it? So they're saying that I'll be able to do this with no denominator and just get an a plus b root 3. Okay, well, let's go with that. This is the equation we're given, 2x minus 3 root 3 equals 1 minus x root 3. I'm going to rewrite this so that all the x's are together on the left side. So I'm adding x root 3 to both sides of the equation, right? You know, where are we going when we're solving algebraic equations like this? We're trying to get this. X by itself equals, yeah? So I'm putting all the x's on the left, and I need to add 3 root 3 to both sides, so this will equal 1 plus 3 root 3. Okay, these terms both have an x, so I can pull that x out and be left with 2 plus root 3 equals 1 plus 3 root 3. All right, let's get that x by itself by dividing both sides of the equation by 2 plus root 3. So we get x equals 1 plus 3 root 3 on 2 plus root 3. Okay. Now you see why it fits with the exercise 7C, because it's turned into a rationalise the denominator, and that denominator is going to equal 1 once it's multiplied by its conjugate. So the conjugate of that denominator is 2 minus root 3. Why is it going to equal 1? Because we're going to have 2 times 2 is 4. Right? We've got our a term there. A squared is 4. The b term is a root 3. Root 3 times root 3 is 3. So we end up with 4 minus 3 is 1. Right? So x will be have a denominator of 1. Right? So we've got a squared, 4, and the b squared, and this equals 1, right? Okay. Now on top, think of this as a binomial product expansion. We'll do it slowly so we don't make a mistake. It's tempting to try and do these in your head, and that's fine as long as you get the right answer. So the first term multiplied is 2, 1 times 2. The outside term, 1 times minus root 3. Okay, that's just minus root 3. The inside, 3 root 3 times 2. Right, so I've got 3 root 3's, and there's 2 of them. That would make 6. We've got plus 6 root 3. And the last term, right, the root 3 times the root 3 is 3. There's a minus, put the minus in. So we've got 3 times 3 is 9. So we're going to end up with x equaling 2 minus 9 is minus 7. And what have I got in the middle there? A 5 root 3. So if it wants to know what a and b are, it didn't really state that, but the a term is a minus 7 and the b is a 5. Okay, so that is question 5 done. Let's look at question 6. Now, I think the way to deal with this question is to treat these as similar triangles. We can do that. So maybe this is not overly familiar to you, but when you get a triangle inside a triangle, and you've got a pair of parallel lines. So here's one that looks quite different. Just making little parallel lines there. All right, the big triangle there, and then this little triangle are similar, right? They're similar because they're sharing an angle, okay? And they're sharing these angles as well, right? So I've drawn this to look like a right angle. But if these are truly parallel lines, then it means all three angles of the triangle have to be the same. And when you have three angles the same, A, you have similar triangles, okay? So this little triangle up the top is similar to this large triangle there. And apologies for the drawing. Using this pen is quite difficult. I really need to find a better way. But that angle there is shared, okay? And because these lines are parallel, those two angles are the same, right? And these angles here are the same. We've got corresponding angles. Okay. So, I think the way to go with this, I'll draw the little triangles. I think there's a couple of things we could do, but the one that's sticking out to me is to compare the ratio of the bottom side, right? So I'm saying x is to 4, so the ratio of x to 4 must be the same as the ratio of root 5 to the length of this longer side. So this longer side through there, okay? Which would be root 3 plus root 5. Root 3 plus root 5. All right. And we're trying to solve for x. I'm going to make some room up the top. So what we really want is x equals, which I can get fairly easily by multiplying by 4. All right, so 4 root 5 all on root 3 plus root 5. Hopefully you can see where this is going now, because it's just turned into another question where we need to rationalize our denominator using a surd conjugate, right? So here we've got an a term and a b term, and there's a plus. So we need to use the conjugate of that, i.e. minus. Oh, my pen's a bit dodgy. Okay, so let's do the top first. We'll get x equals 4 root 5 times root 3. Well, that's 4 root 15. And 4 root 5 times the root 5. Well, the root 5s will times together to equal 5. There's also a minus. So we'll have 5 times 4, which is 20. And what's going on down the bottom? We'll have 3 minus 5, which equals minus 2. And that will actually cancel out. So if I, just to save a bit of space here, let's write the minus 2 in, because I could say, or change colour, that could end up being a 1. This could be minus 2. Right? And here, if I do minus 20 divide minus 2, I would get plus 10. So the final answer will be x equals, let's put the 10 first because it's positive, 10 minus 2 square root 15. And that is your answer for x. Okay, thank you for watching. So these questions aren't too difficult, are they? Might stop the video there, then we'll do question 7.